All right, so we are on chapter 2, and we're going to talk about atoms and radioactivity. And when we talk about atoms and radioactivity, the reason why atoms and radioactivity are so important is because we use radioactive atoms. Let me see if I can move this into a good location. Radioactive elements and radiation to diagnose patients, and we also use it to treat diseases. So like if you think about a PET scan, how does a PET scan work? We know it can detect cancer, but how does it work? Well, how does an X-ray work? So in order to understand how we can apply that to a patient, we have to understand how the simplest form of matter, atoms themselves, behave. And then once we have that understanding, we can apply that to all of our medical applications. So the majority of the chapter is how atoms behave, and then we're going to talk about their application. So you have to know about atoms and their components. So our subatomic particles, we have our basic three. We have protons, electrons, and neutrons. Our protons are charged. Protons have a positive charge, and so we abbreviate them with a P and a little plus sign. So that's right down here. Then you have neutrons, which are neutral, and so when we write their little abbreviation, we write an N and we write a 0 for no charge. And then we have electrons, and electrons are negatively charged. They have a -1 charge. And when you look at this all together, you have protons, neutrons, and electrons in the atom, and the atom's overall charge is 0 because our number of protons is equal to the number of electrons. So that's true in all uncharged atoms. So when we look at where these different parts of the atom are located, the protons and the neutrons are stuck together right in the middle, and we call that the nucleus. And then all of our electrons kind of zing around all over throughout the area around the nucleus. So they're constantly in motion. And because it's really hard to figure out exactly where those electrons are, we call that an electron cloud. They're moving around. They're really difficult to figure out where they are and where they're going and all this kind of stuff. So we call it the electron cloud. And what's really cool is that means that most of an atom is empty space. So even things that we think are hard or solid, like the desk you're at or the computer you're working on or whatever it is, we think of those as solid things. But really most of what everything in the world is made up of is empty space, because the electrons take up the most amount of space in an atom, but they're always moving around. So there aren't that many inside of a huge space. And so we end up having lots and lots of empty space, but it feels solid to us because they're moving so fast. Okay, so when we talk about the parts of the atom, even though the electron's very small, and the proton's very small, and the neutron's very small, they all qualify as matter because they have volume and they take up space. They have volume and they have mass. So they take up space and they weigh something. So most of the mass of the atom lies in the nucleus, and that's the protons and the neutrons. So if you look relatively at the mass, see here's a proton and a neutron, they both have a mass of about 1. So their masses are equivalent. But when we look at an electron's mass is 2,000 times less than that of a single proton or neutron. And so when we're looking at the mass of an atom in calculations and practical applications, we just don't worry about it because it's so small. So when we talk about the mass of an atom, the mass of an atom is really, really small. So we need a particular unit that we use to measure the mass of an atom. So it's very easy to do math and that kind of thing. So we call the mass, that unit for mass of an atom is an AMU, or an atomic mass unit. And by definition, an atomic mass unit is 1/12 the mass of a carbon atom. And that makes sense because there are 12 subatomic particles inside that one carbon atom that contribute to it. So we have 6 protons and 6 neutrons. And we said that 1 proton, right, is basically equal to 1 AMU. And 1 neutron, mole plus, mole 0, is 1 AMU. So if you have 6 protons, so that's times 6, that's going to be 6. And we have 6 neutrons times 6, that's 6. 6 plus 6 is 12. So the mass of one carbon atom is 12 AMU, and you'll see that on the periodic table. So we don't worry about the mass and electron because it's so small, right? So here's an example of what we're looking at. In this case, instead of saying carbon, we're talking about lithium. And so we have lithium metal right here. And if you zoom in on that lithium metal, what you're going to see are lots and lots and lots of the same atom. And those are all lithium atoms. So this is one of those pure substances, right? And then if you took one of those atoms and you zoomed in on it, what you would see is, and this really isn't to scale, but that's okay, that this whole thing here, this is the atom. Here's the nucleus in the center, and all of this space here is the electron cloud. All of that is the electron cloud, but you don't have that many electrons. And I'm going to erase all this, right? But you don't have that many electrons. You only have a few. They're just zinging around and hanging out anywhere they want inside that electron cloud. Not quite anywhere they want. They kind of have spaces they have to be in, but they're hanging out in that cloud. So by definition, in order to be the same element, you have to have atoms that have the same number of protons. So we call that number of protons the atomic number. So number of protons is our atomic number. And you can get that atomic number by going to the periodic table. So when you look at an element, say it's carbon, right? So carbon should have 6 protons, and that's what you'll see in the periodic table. So we call that the atomic number, okay? And that tells me that any atom that has 6 protons is going to be carbon. It has to be carbon. And that's what gives the atom its unique properties. If it had a different number of atoms, it would be a different element. So the carbon atom, atomic number 6, contains 6 protons. So all atoms of carbon have 6 protons. Let's say we went up. If we had 7 protons, now we're not carbon anymore. That's nitrogen. What if we went down? So if we have 6 protons, we're carbon. If we have 5 protons, then we're boron, right? So it turns you into a different element. So the atoms are neutral because however many number of protons you have, if you're carbon and you have 6 protons, then that also means that you have 6 electrons. So if you have 6 positive charges, 2, 3, 4, 5, 6, and 6 negative charges, so it's like plus 6 minus 6 equals what? 0. So the atoms are neutral. They have no charge. So all neutral carbon atoms contain 6 electrons. So whenever you see that 6 here, that 6 is going to tell you number of protons, and it's going to tell you number of electrons. So here's our example, right? We talked about carbon, how carbon has an atomic number of 6. So that tells us that we have 6 protons. And it also tells us that if we count them, 1, 2, 3, 4, 5, 6 electrons. So this is 6 electrons. Let's look at another example. Let's look at lithium. Lithium's atomic number is 3. So what we should have are 3, here's 1, 2, 3 protons, and then we have 1, 2, 3 electrons, okay? Now we're gonna look at mass number. When you think about mass number is something we're gonna count. If it's a number, you count it, right? So what takes up mass inside of an atom? There are 2 things that take up mass inside of an atom. And those 2 things, you can't see because my picture's there. The 2 things that take up mass are a proton and a neutron, basically because we don't count the electron. So it's the count of protons and neutrons, and that's what gives us our mass number. So here's our formula. Oops, too much technology, y'all. All right, let's see if I can make that small. All right, so we have our formula here. Our mass number is equal to number of protons plus number of neutrons. So if you know those 2 things, if you know the atomic number and you know the mass number, you can determine the number of all of our subatomic particles, right? So let's use our example. We have carbon. So we know carbon, we got this atomic number. This is on the periodic table, right? We said if you look, carbon, it has a 6. It has a number, another number at the bottom, but we're not going to worry about that yet. So the atomic number is the one on top on the periodic table. So that's 6. So that tells us, the atomic number tells us we have 6 protons. It also tells us that we have 6 electrons. Now, our mass number, on the other hand, our mass number is the number of protons plus neutrons. And so we said protons plus neutrons, in this case for carbon, is equal to 12. So what can we figure out? Well, I know, see if I do this, I know that my number of protons is 6 plus some number x is equal to 12. So I take 12 minus 6 and I get x, so x is 6. And x is really our number of neutrons. So we were able to get number of protons, number of electrons, and our number of neutrons just from this one symbolic notation for our atom. So you're going to have to be able to do that. So whenever you do this, here's kind of a step-by-step what you should do. Find the element on the periodic table. In this case, I'm going to give you an example, neon 20. This is the one we want to figure out. We're going to use the atomic number to find the number of protons and electrons. Then we're going to use the mass number to find the number of neutrons. So we know if this is neon right here, this is going to be our atomic number. And then whenever you're given an element and then a dash and a number, that number is the mass number, okay? So we're going to use the atomic number, step 2, use the atomic number to find the number of protons and electrons. So our atomic number is equal to the number of protons. So we have 10 protons. That atomic number also tells us that we have 10 electrons. Then we're going to use the mass number. So our mass number is 20. So what that is telling us is 20 is equal to number of neutrons plus number of protons. We know our number of protons is 10. So that means our number of neutrons is 20 minus 10. So our number of neutrons is equal to 10. So we found we found our neutrons, we found our electrons, and we found our protons. So you have to be able to do that. Okay, so I'm going to go and do some problems real quick. We're going to switch over. We're going to do these top 4 in class, so I'm going to switch over that. All right, look at 2.5. How can you determine the following? The number of protons present in an atom. What are you going to look for the number of protons? You're going to look for the atomic number. All right, that's the atomic number. So if we look here at carbon, carbon 6, we're looking at the atomic number. So you could say on the periodic table if you like. The number of neutrons present in an atom. So our neutrons are equal to our mass number minus the number of protons, right? Or you could say that the other way around. This is what we had been saying. Mass number is equal to number of protons plus number of neutrons. It's saying the same thing. It's just rearranging the formula, okay? And then lastly, we're looking for the number of electrons. Number of electrons is equal to number of protons, and we know that the number of protons is our atomic number, right? So that gives you kind of a roadmap of how to get there. All right, provide the name and atomic symbol of the element that has the following atomic number. So to do this, what you are going to need is a periodic table. So let's put it in, insert. Okay, so here we go. We got our periodic table. Move it over here. All right, so provide the name and atomic symbol of the element that has the following atomic number. All right. Okay, so we're looking at 7. So we're going to come over here and we're going to say that it's N, that's our atomic symbol, and our name is nitrogen. Right? Okay. Then we're going to do 16. So we're going to come over here and we're going to say 16 right here. S is sulfur. Sulfur, okay? Now we're going all the way to 50. So right here, 50, SN is 10. SN is 10, that's how I always remember it. Okay, let's see, number 30. Go on to number 30 is zinc, ZN, zinc, right? And it's really easy if you have the atomic number because they're in numeric order on the periodic table, so it makes your life real easy. Okay, and then the last one, we're looking for number 27, is cobalt, CO. Right? Okay. All right. All right, so we're going on to 9. What is the mass number for an oxygen atom that contains 8 neutrons? Right? Okay, so we know it's oxygen. So we're going to go to our periodic table. I'm going to go find oxygen. And if I zoom in right here, right, here's oxygen. And so I know my atomic number of oxygen is 8. That's that number right there, number 8. So that's my atomic number. So what does my atomic number tell me? My atomic number tells me atomic number is equal to number of protons. So for oxygen, our number of protons is equal to 8, right? So what is the mass number? The mass number is equal to our protons plus our neutrons. So our mass number is equal to number of protons, which we said was 8, plus 8 neutrons. 8 and 8 is 16. So our mass number is 16. Okay, determine the number of protons, neutrons, and electrons in the following atoms. An iodine atom that has a mass number of 131. Okay, so when we do this, when we say iodine, right, we have 131, and now we're looking for protons, neutrons, and electrons. So let's see if I can do this over here. Protons, neutrons, and electrons, and we'll just kind of do a little table there, right? Because we have 2, okay? So if we go look at our periodic table, if we look for iodine, here's iodine right here. Iodine has an atomic number of 53, so I'm going to go and put that in, and I'm going to say iodine has 53, right? And this is our symbolic notation, where we have atomic number, which is equal to our number of protons, and then we have this as our mass number, which is protons plus neutrons, okay? So can we go in and fill in some of this? We know our atomic number is the number of protons, so we said that's 53. Now our number of electrons must be the same, so that's also 53. I should really move that up. Let's see if I can kind of make that a little easier to read. Protons, neutrons, electrons. Okay. So now I need to know my neutrons. How do I figure out my neutrons? I'm going to say, this is kind of why I like having this setup on my atom here, is I do 131 minus 53, because my mass number right here, if I subtract my atomic number from my mass number, I'm going to get number of neutrons. So you can do this, just do that, that really quick subtraction. And I like that because it's already set up for you. So you don't have to go back and do it again. So if you subtract the 2, you should get 78. So my number of neutrons, I'm going to put here as 78. Okay? That's a good way to remember which one's on top and which one's on the bottom. Your subtraction always works out because the bigger number should be on the top, smaller number on the bottom. So it's a good little trick, right? Okay, a potassium atom that has a mass number of 39. Okay, so I'm going to go look for potassium. When I look over here, I'm going to find potassium right here. I see that my atomic number is 19. So I'm going to come down. I'm going to say, okay, I have potassium atom. It has an atomic number of 19, and it has a mass number of 39. See how it's nice and lined up there for me? So let me see. Oh, no wonder. I was doing too much of a grid, but that's okay. Okay, so my number of protons is 19. My number of electrons is 19 because I know my protons are equal to my electrons in a neutral atom. And then all I have to do is subtract the two. So when I subtract the two, right, 39 minus 19, I get 20. Okay. All right, 2.13. Write the symbolic notation for atoms with 5 protons and 6 neutrons. So if I'm 5 protons, I need to go up to my periodic table and I need to go find that. 5 protons. Let me kind of erase. Let me erase this. There's so much going on. Okay. So 5 protons. I know that 5 protons, whoa, 5 protons must be, stop, boron right there. Now, me and technology sometimes don't get along. Boron. Okay, so that's a B. So boron. There's boron. And I know I have 5 protons, so that's my number at the bottom. So my bigger number is going to go up top. Remember that bigger number is always on top. How do you get that bigger number? You add protons plus neutrons. Okay, so 5 plus 6 gives me 11. So there's my symbol. All right, let's change color. Something that will do B on this side. 35 protons and 46 neutrons. So I know my 35 is going to go on the bottom. And then I'm going to have to add 35 plus 46, right? Carry 1, 4, 5, 6, 7, 8, 81, right? So my 81 is going to go on the top, but I got to go find that element. And that element has 35 protons. So I'm going to go up here and I'm going to look and I'm going to find 35 protons is bromine, Br. So I can do this and I do Br. Okay, that's my notation. All right, let's see. We got a few more. 14 protons and 14 neutrons. I know my 14 protons is going to go on the bottom, and then I need to add the protons and neutrons. So I'm going to get 28. So 14 plus 14 is 28. Now I'm going to use this 14 protons, and I'm going to go to the periodic table. I'm going to go hunt down what has 14 protons. There's only one element, and that is silicon. So let's go down here, and let's write that as silicon. Okay. And let's see. We're almost done. We're getting close. All right. Then we have 54 protons and 70 neutrons. So I know 54 is going to go on the bottom. And I know that I need to add 54 plus, let's do it, 70, right? 4, 12, 124, so 124. And then I'm going to look for 54 protons. So I'm going to look up here. And I'm going to say, where's 54? 54, right here, xenon. Xenon, 54. So Xu. Okay. All right, now we're going to kind of switch gears and we're going to go the opposite way. Determine the number of protons, neutrons, and electrons, and we're given the little symbols, right? All right, so let's see if I can make a little grid here, a nice grid. I thought I was going to get pretty lines, but apparently I'm not. Okay, so I want number of protons, neutrons, and electrons. Okay, my 8 right there, this 8 is telling me that I have 8 protons, and it's also telling me I have 8 electrons. So now you just subtract the 18 minus 8, and you get 10 neutrons. It's really nice and easy. Calcium, 20, 20. That's my atomic number. Now my mass number, 40, minus my atomic number is 20. Ag, silver, we got 47, 47. Then you have to subtract and you get 61, okay? And then PB, lead is PB, so we have 82, we have 82. It's so nice and easy to fill those two in. And then you want to subtract the 2, so we got 12, 125, okay? So that's how you go back and forth. And that's where we're going to stop. All right. Y'all have a good rest of your day, whatever time it is.